What's up, everybody? This is Ryan here, and today I'm going to be taking you on a magical journey through the land of test-driven development with Kotlin, coroutines, and Mockk, which is a mocking framework for Kotlin. And I would just like to personally thank the creator of this particular tool, Oleksiy Pilipenko, forgive me if I mispronounce that at all, for not only creating Mockk, but also doing me a favor and giving me some feedback on my implementation of it and JUnit 5 and other things. So just a big shout out to Oleksiy there. Thank you very much. So basically what's going to go on is in an older code base of mine, I'm basically changing around the way I have my view, which is like a user interface class, talk to my decision maker class, which happens to be a presenter, and to sort of like an event-based system, which sounds complicated. It's really not. It's actually simpler than how I used to do it. And one of the benefits of taking this kind of event-based producer-consumer result and then having these things talk to each other through interfaces or just some contract, then if you basically test every function in that contract, then you can more or less cover everything not everything, but most of the things you really want to be worried about when it comes to testing the different parts of an architecture. So basically the point of this tutorial is to teach people how to apply test-driven development, which is basically you build your tests as you're writing the code, the actual unit, the actual object that you're building, you know, whatever size it is. And by building it through testing and using tests as like a scaffolding, then you'll tend to solve bugs or pick up on typing error type bugs and just general bugs a lot quicker. You'll be able to basically verify each unit, which is just a single execution point within an object. Usually it's just you're testing a single function, but it might end up calling several other functions as a result. That's fine, but you can verify kind of each unit of the thing you want to test, each part of your architecture individually, so then you can be sure that you're not sort of like building on like mistake on top of mistake on top of that kind of thing. So just bear with me. This video isn't going to be super short. A lot of people complain about the length of some of my videos, and I really like to emphasize to people watching this, just because a lot of people will try to explain a topic like this in 5 or 10 minutes, doesn't mean they've taught you how to actually do it in like a production environment. What I'm showing you here is something I was going to do anyway that involves test-driven development, so I'll be taking you along with that process and doing my best to explain it as I go. And so what I'll do is I'll give you a quick preview of what the application's architecture looks like, just in like a visual diagram, and then we'll kind of just jump into the code. Okay, so let's take a quick look at the architecture that this application employs. So we of course have in the front end view, which is going to be a fragment. Now most front-end architectures, whether you do whatever model view, whatever thing you pick, model view this, model view that, you're generally speaking going to have some kind of view, you're going to have some kind of decision maker class, and you're going to have some kind of front-end data store. So basically in this project we have a presenter which acts as a front-end decision maker, and we have a view model which acts as the front-end data store for temporary data. So technically this isn't model view model, it's closer to model view presenter, but I actually call my particular style of architecture literally as model view whatever, because I'm tired of using other people's names when people don't even implement these things the same way anyways. So that's anyways the basic gist of it. You could think of it like model view presenter plus view model if you really want to get picky. In any case, the decision maker is going to be talking to, in this case, a repository. So I don't have time to go into that in this particular video, but this is the repository pattern. So basically when you're talking from the front end to the back end, architecturally speaking, you're going to want to do that usually through like a facade or a repository pattern or just use an interface. It's just generally advisable. Anyways, that's beside the point of this particular video, but here's a quick glimpse, as you can see here, like a visual idea. And then if I look at the package structure of this application, of course we have our presenter, we have our view, we have our view model, and then we have the backend. The backend is spoken to through this domain package here. There's going to be a repository interface. So that's basically what all the different things that our presenter are going to talk to. So what's going to happen in this video is I'm going to basically rebuild the presenter specifically using test-driven development. Now, one of the important things to remember about testing is, so some people will tell you you literally have to do 100% code coverage and everything should be tested. I can't say that's wrong. I also can't say that I do that. However, I do recommend, for a lot of people getting into testing, they wonder, well, where should I get started? What should I test? So let me keep it really simple for you. Test the classes that have lots of logic, simply put. If it doesn't have a whole bunch of logic in it, and you could almost test it just by looking at it closely for a couple seconds, some people would argue you still have to test it, but if you're not going to do anything else, test things like presenters or controllers or view models if you do like to fill them up with logic and make them an even more poor choice of name. Anyways, carrying on. Okay, so what I'm going to do for everybody is I'm going to make a special commit to this repository, which will serve as the starting point for this hands-on tutorial. And what the starting point is going to be is that we're going to start with our presenter in this state here, and then we're going to start with basically an empty test class. It's always the one that's off the screen. Always. There we go. Yeah, we're going to start with just an empty test class. So I'll build out the whole test class, and also we'll build out most of the presenters. So hop down into the description box below and you will find the starting point. So if you want to follow along with this, I do suggest that you do that for the best learning experience, but you know, whatever. I'm not your mom or something like that, so do whatever the hell you want to do. Alrighty then, time to get this train wreck moving, people. So let's get started. So where we're going to begin from is where I would normally start in my development process. So I like to build these things for each feature of my application, and since this is a calculator app, this happens to be the only feature in the application. What I like to do is for each feature, I'll build out this contract class. So basically what this does is it's kind of a place where I can do some preliminary planning of all of the different things that I expect to sort of send and receive from the different parts of my front-end architecture. So as I just talked about before, we have a view model, a presenter, and so what I've done here is I've used this is a Kotlin enum class to represent every sort of button that the calculator the user can press on the calculator. And so you might be wondering, when do I want to use an enum class? Well, the short answer is that enums are great for creating a restricted set of values. So values just being these sorts of things here. So they could be strings, they could be numbers. We're just saying these are expressly what I want to do. So you could use this using something like constants. I just find this a little bit easier and a little more legible, but yeah. Now, one of the close cousins to the enum class is the sealed class. When do I want to use a sealed class? When I want to create a restricted class or type hierarchy, depending on how you want to put it. When I want to create a restricted class or type hierarchy. So what I've chosen to do here is basically every possible event that can occur in the front end is going to be represented as one sort of one class in my type hierarchy. So for the ones that don't have any value, I just return this just an object, and you'll see how we use this with a when matcher shortly. And for the ones that do have values, I specify the values that are sort of allowed to be inputted as being this enum class inputs here. So that basically kind of creates very tight restriction on both values and the events. And so why do I bother doing all of that? Now when I go to writing my tests, all I really have to do is make sure that I cover every one of these events with at least a couple tests. So this approach I find works really well, and I would suggest you adopt it if you don't do something similar when you're communicating with your front end to your decision maker class, whatever it's called. Okay, so we have our contract set up, and we have the basic constructor for our presenter set up. Again, I am cheating a little bit because I already know ahead of time it's going to need this observer from the view model. And as far as what coroutine scope means, it just means I have to have this particular value here, and I can't go in detail on coroutines in this particular application, but you might kind of pick up a little bit of information as we go. This isn't even technically necessary for this application. I'm just using it on the off chance that calculating some value happens to be a long-running operation, but you could actually build this application in an entirely synchronous way, and it shouldn't have any issues the way it is right now. Anyways, what we're going to do is I'm going to start by just getting all of my method stubs. So I have this thing implementing my contract. I'm going to hit Alt-Enter, and then we'll select the events that are required. And there we are. So as you can see, we have our onEvent class here, which is going to act. This will act as a dispatcher function. And we'll see what onChange does later on. I might not even bother. All it really does is it just kind of updates the display of the view automatically when onChange is fired. So we won't do every. I won't take you through test-driven development with every function. Excuse me, but we will do a few of them. So I've got this set up. Now I'm going to hop into my presenter test. So generally speaking, I just call these things calculator, or sorry, I just call it the name of the class I want to test, and then I just add test to the end of it. So how do we actually build these things? So first we set up our mock objects, our mock actors. So here's a really key point. People are always asking, why should I do dependency injection? So this is dependency injection right here. It's giving this presenter its arguments. And the reason why is that when I combine dependency injection with a mocking framework or interfaces, it means I can, in tests, give fake versions to the class I want to test, and then that way I can test this thing in kind of an isolated environment. So what we're going to do is we're going to start with the things that my presenter needs. So I'm going to make the presenter itself into a val. So we're going to say val presenter equals calculator presenter. So we're going to create the actual thing, and then this is going to kind of tell me what I need. So I need a view, I need a view model. Okay, so anyways, carrying on, view model, eval. So we'll talk about what that is later. That's our repository pattern. Then we need a dispatcher, which I'm not sure if I really need that, but we'll give it in there now. Okay, so obviously next thing I'll need to do is create these things. So one of the things right off the bat is we can kind of do this build process by the act of like unscrewing up our code. Getting rid of all the red is kind of what's going to drive our build process. We'll see how that works once I start actually running tests. So let's get to our things here. So first we have the, might as well make these private. So view is going to be iViewContract.view. So if you're wondering where, sorry, let me just, oops, fix this up so y'all can see it better. If you're wondering where this comes from, it comes from this iViewContract class here. Okay, so, and then we need to So here's where Mockk comes in. So what we're going to do is we're going to make each of these things into a mock. So let me just do it and I'll explain what I'm talking about here. So make these things into mocks. So this is a Mockk DSL function. So what this is going to do is we literally just slap this thing in here. This is why I love Mockk. And all of a sudden we're able to give this thing to our presenter. So generally what's going to happen is we're going to call special functions on this mock to sort of set up what we want it to. So if the presenter calls a function on it, it's going to return some generic response. For some of our mocks, I don't really care too much about specific responses. So I'm actually going to use an option in Mockk for some of these, which is going to be relaxed equals true. So it's not going to like throw an error if this thing has some function called on it and it doesn't have a mock response prepared. So sometimes you don't want to do that, sometimes you don't really care. So I'm just going to add this in for the view model and the view. Now why I'm going to do that is because I am still going to check that they are called. I just don't care so much about returning a particular response. So hopefully that's fairly clear. So we also have, of course, this is going to be the view model. So this will be iViewContract.viewModel. And then we're also going to have our eval class. So that was going to be iEvaluator, just like that. That thing should not be relaxed. Sorry, this thing should. As you can see, I'm doing this kind of on the fly here, so it's going to be a little ugly. Okay, so we've got those two, and then what's the other one I'm looking at here? Right, our dispatcher class. And the dispatcher is just for coroutines magic. What we do is, so that's going to be of type dispatcher provider. What we basically do with the dispatcher is when we want to run unit tests with our coroutines, then we want to be using it on basically the, it's escaping my brain, dispatchers.unconfined. So you'll see what I mean in a minute. So anyways, that's kind of the first step. So we create the thing we want to test. We want the real version of the class we want to test. And then we create the things that, the dependencies it needs to talk to in order to do what it needs to do. And you'll notice that we've got 4 here and we've got 4 here. So we can go ahead and get started with the rest of the TDD process. Okay, so the next thing we're going to do is we are going to start building out our test classes. So I'm going to do this in kind of a weird, awkward way for me, because normally I would kind of have this going on the other side of the application. But what I'm going to do is I'm going to have basically my view contract class open. In fact, I don't think I'll do split screen because that would be ugly for both of us. But I'm going to have this iViewContract class basically open just on my side monitor here. This is how I would actually do this. And I'm going to use that as my guide for writing all the tests that I need to write for my presenter. So I'm going to go ahead and do that, drag that over, and then we'll just get started writing out these tests. So as I said before, what we want to do is we want to look at all the different things. Actually, let me pull that back in here for a minute. We basically want to go through this sealed class and make sure that we have tests written for every one of these different events here that we've represented in this sealed class. So we're going to go ahead and get started here. So the way that we actually do that is, sorry, just juggling windows here. So we're going to create our test functions. So we say @test, for example. If you're using JUnit 5, select the JUnit.Jupyter API. That's JUnit 5. And then what we'll do is we'll just start writing out tests. So here's a quick little tip. If you use the backtick character that looks like that, it's just under the escape key usually, or the tilde key, or however it's pronounced. You can actually make function names that are written in plain English. And of course you have to finish it off. But this actually totally works fine, and this is what I would suggest you do. This is better than having to do the camel case type thing. And but we're not going to actually write that in there. We'll write something intelligent. So what I usually do is I will write most of one function, and then I'll kind of just do a lot of copy paste. I probably should have like a library for building this out, but I'm too damn lazy to find one or build one myself. So we're going to start with on start, and I didn't even really need to do anything other than that as far as that one in particular is called. So what we're going to want to do is for every primary test, we're going to want to write out a basic comment of what we want to do in onStart. So when onStart is called, bind the basically the view listeners to the presenter. So onStart basically means that the view is created, the application's pretty much ready to go, so we can go ahead and do some binding work. So right off the top of my head, I know this is going to require a view. So we're going to be telling this view some particular function. So if I look over on my contract class, I see we have the function bind event listener. So what I'm going to do is we're going to say every. Actually, we don't need to make a mock response here. We're going to actually verify. So this is another thing we can do in mock case. So verify basically checks to see if this particular function was called on this mock. So when I say this mock, we're talking about view. So verify that we saw view.bind event listener, and that's actually all I need to type there. So if I execute this test, then that's of course going to fail because it won't be called, but that won't be the only thing I don't think that I want to do in onStart. Let me just double check on that. Okay, so we're also going to want to set up we're going to want to make sure we set up our view model. So that's going to be view model dot set observer, and we're going to return this. And no, we're not going to return this. We're going to return presenter. I forgot that I'm not in a presenter currently. Yep, so this is okay because our presenter implements that particular interface. And how this works is every time we change the view model, I want to basically update the user interface as a consequence of that. So that's why we use this observer pattern here. I just want it to be automatic and fire right away. So these are the two things that I really want to make sure get called in onStart. I might figure out that there's more things in a moment, but this is part of the test-driven development process. So far, it looks like this is relatively accurate. Bind the view listeners to the presenter and set observer for view model. So these long sentences here, they're not just to waste time. Not only are they going to help you build these methods or functions on the fly, but when someone else comes to read this, they're going to be able to look at these different functions and figure out in relatively minimal amount of time what they need to do if they're explained well. So we've figured out what behavior we want to see. Now at this point we can move on and we can say, let's do, we're going to call the particular event that we want to test, the particular unit. So, oops, that's totally not what I wanted. So we're going to say this is the unit I would like to test. So if you're wondering about testing and this terminology, I'm going to link in the description box below to an article on Medium I wrote, and this should kind of explain what I'm doing here in a lengthier, simplified way. So we're going to test the unit, which is generally going to be one function, one sort of part of one function in a contract essentially. So we're going to say, I believe it was handle event. No, what did I call that? Let me just check my contract class. On event is what it's called. So presenter.onEvent, and then we select the appropriate, I gotta pull this in so that you guys can see it, guys and girls. Statistically speaking, guys, but there are a few girls watching. And yeah, so we're gonna call this particular, whatever event we wanna test here in particular, this is gonna be onStart. So we're gonna say onStart. And we'll make sure we're doing our view event class. And so what's going to happen is that's going to fire this particular function in our presenter. So that's kind of a basic setup that I want to see in all of the different functions. So what I'm going to do now is off camera, I'm going to basically create all of the different tests that I think I will need up front. We can still add some more later. And I'll come back once I've got to something more interesting and different. Okay, so this isn't just for the camera. While I was busy basically doing this busy work here, I was going to do it all off camera, but I realized after writing out a couple of these functions, but not actually implementing them, just writing explanations and some stub work here and some names, I figured out that having a separate sealed class for decimal doesn't really make sense, because a decimal is just another input character. Alright, so with that, I'm just going to go ahead and delete this particular test case here, and I need to make sure to fix it in the different classes that affected. So we're no longer going to have this particular callback here on decimal click. I'm going to rename this just to accommodate and make things a little bit easier to on operand click, because I couldn't decide of a better excuse to lump a decimal in with these particular items here. So I'm just going to go ahead and hit Control D, and we're going to call this decimal, and that's going to be a decimal, and that kind of eliminates one whole test case. So as you can see here, I've got basically every single one of these test cases set up, and what we'll do now is we'll just try executing our class here, our test cases. So you can do that by hitting this green circle icon. And we have a build failure, so it looks like I forgot to implement my change in the view. Yes, I did. Alright, so what we'll do here is we're going to call this on operand click. Yes, and that's going to be inputs dot, let's see, decimal. There we go. As you can see, I have a terrible memory. Anyways, moving on. Let's see if we can rerun those tests. Okay, so I'm getting legit errors while I'm trying to put this tutorial together, which is the perfect time to try and learn some more things. So what we're going to do is I've got this error, backend internal error, blah, 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 and I can't even see the rest of the error message. So what I'm going to do is I'm going to hit the Gradle tab over here to run a Gradle script. And we're going to go, so we're going to type test, which is going to execute our unit tests, and then we're going to give it the argument -- info. And hopefully that'll give us a better idea of what's going on. Looks like we have a stack trace. Okay, so I can't draw too much from that other than it's probably this function here. So let's try changing this. Just throwing out ideas there. Okay, it actually worked. Okay, anyways, back to test-driven development stuff. So like I say, I wanted to show everyone the whole natural process here. I'm really only cutting out superfluous stuff. So what we're going to do next is, so I know that these tests are functioning, and they should be failing. Yeah. So at this point we have failing unit tests, which is exactly what I'm looking for. Now what I'm going to do is I'm going to go through them one by one to just try and make sure that they're well formed. I'm not necessarily concerned about running all of them, and at this point I'm going to try and take a more deliberate approach, because one of the problems that you can run into with testing is that, especially if you do a whole bunch of copy and paste, you want to make sure that you don't have improperly formed tests. So this part you don't really want to do quickly. So what I'll do is I'll take you through how I would approach this first in this example here for onStart. So we have a failing unit test, so we can go ahead and start to implement the unit that we want to implement. So I'm just going to, again, double check on what we want to do in onStart. Okay, it looks like we want to make sure that we call view.bind event listeners, and we want to make sure that we call set observer. So that's kind of my rough idea of how to approach this. And then I'm going to go into the presenter. And then first thing we're going to do is we're going to set up a when matcher for these different events. There's children screaming outside in the hallway. Good old apartment living. Anyways, carrying on. So in this when matcher, we're going to, of course, supply event. And this is where the sealed class is going to come in real handy here. So the first thing we want to test is, of course, the onStart event. Surprised I even remembered that. And how we can do that is we can type view event dot onStart. And we type this arrow thingy and then a lambda. Or actually, we can just type a single function. And so what I'm going to type here is I'm actually just going to kind of duplicate this scheme here, and I'm just going to type onStart just so it's not very ambiguous. That's going to show up in red. I'm going to hit Alt Enter, then we're going to create function onStart. So as you can see here, I'm leaning on my tooling, so to speak, Android Studio, to generate as much of this code as possible. So in onStart, like I said before, I want to make sure that I call view.bind event listener and view.setObserver. So I'm even just going to copy and paste that crap in here, just like that. And in this case, our unit is pretty damn simple. So we're not going to pass presenter, we're going to pass this. And I believe that's all I want to do. Let me just double check with the contract. So we're binding the event listener, display will be blank. Yeah, everything looks good to me. And as far as the view model is concerned, we don't need to set its display state. So that should be good. What we're going to do next is I am going to rerun this test and see if it failed. Oh yeah, that's what we like to see. Give me the green. Here we go. Okay, so as you can see, that's kind of how we're going to go about applying test-driven development. Let me do one more complicated example, and then I'll build them all out, and we'll kind of see where we get to from there.